Hello pharma guys, welcome to our channel Easy Learn Pharma. So my dear students, today I am going to discuss about ideal qualities of a good suspension. So what is that? And that is ideal qualities. Okay. So my dear students, today I am going to discuss about ideal qualities of a good suspension. So what do you mean? That means what are the qualities should have a good suspension? Okay, that's why you can say कि that is the good suspension. Okay, that means what are the qualities are there? That's why according to the qualities you can say कि that is the good suspension. So now come to the point. So my dear students, before going to the ideal qualities of a good suspension, first of all you should know what do you mean by pharmaceutical suspension. That's why you can easily understand what I am telling regarding the ideal qualities of a good suspension. Okay, so what do you mean by pharmaceutical suspension? Now, the pharmaceutical suspension are the biphasic liquid dosage form in which very finely divided solid particles are uniformly dispersed in the dispersion medium by using the suspending agent. Okay, so students, from this sentence what we understand, so first of all look at the figure. That's why you can easily understand what I am telling regarding the ideal qualities of a good suspension. Okay, so my dear students, always remember in the pharmaceutical suspension, solid particle always act as a dispersed phase. Okay, and liquid medium always act as a dispersion medium. Okay, so my dear students, in the pharmaceutical emulsion it is of two types, oil in water and water in oil. Okay, according to the type of emulsion it will vary whether it is continuous phase, whether the oil is continuous phase or it is a dispersed phase. But in the pharmaceutical suspension always solid particles act as a dispersed phase and liquid medium act as a dispersion medium. So my dear students, look at the figure. This one is the pharmaceutical suspension. Okay, so this one is the container and this one is the continuous phase, or you can say that is the dispersion medium, and this one is dispersed phase. Dispersed phase. Okay, so my dear students, this figure, okay, all the solid particles are very finely divided solid particles. Okay, so these are the solid particles act as a dispersed phase, and all the solid particles are very finely divided. So very finely divided solid particles are uniformly distributed in the dispersion medium by using the suspending agent. So my dear students, what we understand from this sentence? Now from this sentence we understand all the solid particles should be uniformly dispersed throughout the dispersion medium. When you have to administer the suspension, in that time all the solid particles should be uniformly dispersed throughout the dispersion medium. That's why you can take the accurate amount of dose. So my dear students, so what is the first qualities of a good suspension? And during the administration all the solid particles are uniformly dispersed throughout the dispersion medium. Clear? Now the next point, all the solid particles or all the dispersed particles should be uniform size. Okay, that should be uniform size. Okay, so if all the particles are not maintain the uniform size, so it cannot dispersed at uniformly. So when all the particles maintain the uniform size, in that time when you are steering properly or when you are shaking properly, in that time all the solid particles are uniformly dispersed throughout the medium. Otherwise it will be problem arise in the pharmaceutical suspension. Okay, and that size should be 0.5 micrometer to 5 micrometer. Okay, so what is the particle size ranges of a good suspension? 0.5 micrometer to 5 micrometer, that is the particle size range of a good suspension. Clear? So now the next parameter or the next qualities of a good suspension. After preparation, okay, after preparation the suspension, when you are storing, or after preparation of suspension, when you are store the suspension, in that time will be marked all the solid particles during the storage condition. Okay, during the storage condition, all the solid particles are sedimented on the surface, are sedimented on the surface. So my dear students, why all the particles are sedimented on the surface? Now because all the solid particles are not dissolved in the medium, but all the particles are dispersed in the medium. That's why all the particles after some time, when you are stored properly, in that time during the storage condition, all the particles are sedimented on the surface. Okay, so my dear students, all the another qualities of a good suspension. Now all the solid particles are sedimented slowly on the surface. Okay, slowly. The sedimented, it will be slowly. So why if the rate of sedimentation, or if the solid particles are sedimented quickly, so what will be happen? Okay, so if the solid particles are sedimented on the surface very rapidly or quickly, so what type of problems will be arise? Okay, I'm giving one example so that you can easily understand which type of problem will be arise due to rapid sedimentation of the solid particles on the surface. Okay, suppose the physician prescribed to you, you have to take the 10 ml, you have to take the 10 ml suspension in a, okay, you have to take the 10 ml suspension 3 times a day. Okay, the physician prescribed to you, you have to take the 10 ml suspension 3 times a day. Okay, that means one dose is the 10 ml. Okay, but in that time 5 ml container, sorry, 5 ml cap is there. Okay, but in that time 5 ml cap is there. So how to take the 10 ml dose? So how to take the 10 ml? And definitely in that time you have to take the 2 times, you have to take the 2 times. Okay, so when you have to take the 2 times, in that time it maintain the 10 ml suspension, or it maintain the 10 ml dose. Okay, acha, so before taking or before administration the suspension, you have to shake well properly. Why? Now because when you have to shake thoroughly, or when you have to shake thoroughly, in that time all the solid particles are again redispersed throughout the medium. Okay, and in that time you have to take the first dose. Okay, you take the first dose. Okay, and after that, when you have to take the second dose, if in that time all the particles within fraction of time, if all the particles are sedimented on the surface very rapidly, and definitely when you have to take the second dose, in that time only liquid particles or only liquid medium comes out from the container. Why? Because within a fraction of time all the solid particles are sedimented on the surface, and you can't shake well in that time, because you have to shake already before taking the 5 ml. Okay, so that is the patient incompliance, or that is the patient not acceptance. Okay, so that's why all the solid particles should be settle down slowly. Okay, that's why you can take the accurate amount of dose during the administration, and it is a patient acceptance. Clear? So the third qualities of a good suspension, now all the solid particles settle down slowly, and the another qualities of a good suspension will readily redispersed again. Okay, those solid particles are sedimented on the surface, that solid particles readily redispersed again throughout the medium on gently shaking. That means when you have to, sorry, before taking the, or before administration, or before taking the suspension, when you are shaking thoroughly, in that time, if if the particles, or if the solid particles are not redispersed, okay, if the solid particles are not redispersed throughout the medium, and definitely you can take the accurate amount of dose, because in that time only liquid vehicle comes out from the container. Okay, that's why the another qualities of a good suspension, it will readily redispersed again throughout the medium. That's why you can take the accurate amount of dose. Clear? So the first qualities of a good suspension, what? Now the first qualities of a good suspension, all the solid particles should be uniformly distributed throughout the medium. Okay, and all the solid particles should be maintained the uniform size. And the third qualities of a good suspension, all the solid particles are slowly settled down on the surface and readily redisperse on gently shaking throughout the medium. Clear? And the next parameter is it should be chemically inert. And the last qualities of a good suspension is it should be physical, it should be maintain the chemical stability. Okay, it should be maintain the chemical stability and physical stability and it should have a patient or it should be a patient acceptance. Okay, so these are the qualities of a good suspension. Next I am going to discuss about the most important portion of a pharmaceutical suspension, that is the difference between flocculated and deflocculated or non-flocculated suspension. Okay, most probably 5 marks question will be arise from this, from the pharmaceutical suspension, that is the difference between the flocculated and D or non-flocculated suspension. Okay, so my dear students, now I am going to discuss about the differentiate between flocculated and D or non-flocculated suspension. Okay, so let's start. Flocculated suspension. So what do you mean by flocculated suspension? Okay, what do you mean by flocculated? The flocculated means that is it forms a flux. Okay, so what do you mean by flocculated? That it forms a flux. So what do you mean by flux? Now flux means small particles attached to each other and form a one mass. Okay, small particles attached to each other and forms a one mass, that is the flux. Clear? So now come to the point. Flocculated suspension. Okay, what do you mean by flocculated suspension? And definitely in the flocculated suspension, the flux will be formed. So how? So look at the figure so that you can easily understand what I am telling regarding the flocculated suspension. Okay, so all of you know what do you mean by pharmaceutical suspension? Okay, so my dear students, all of you know what do you mean by a pharmaceutical suspension? Now the solid particles are uniformly dispersed throughout the dispersion medium by using the suspending agent. So that is a good suspension. Now I am telling you that is the good suspension. Okay, so how to find out if this one is the flocculated suspension and this one is the deflocculated suspension? Okay, so in the flocculated suspension, all the solid particles are loosely aggregates and it form a, okay, all the solid particles are loosely aggregates and attached to each other and it form a network like structure. Okay, so my dear students, what I am telling now, in the flocculated suspension, all the solid particles are loosely aggregates and attached to each other and form a network-like structure. Okay, and form a network-like structure. Okay, so it forms a flux. Okay, it forms a flux. Okay, so look at the figure. Now, first the pharmaceutical suspensions are there. Okay, all the solid particles are uniformly dispersed in this medium, but in the flocculated suspension, okay, in the flocculated suspension, all the solid particles are loosely aggregates, and all the particles are attached to each other and form a network-like structure. Okay, and forms a flux. So that is the flux. Okay, that is the flux. Clear? So it forms after attaching all the particles, it forms a network-like structure and forms a flux. But in case of non-flocculated suspension, all the solid particles are exist in a separate entity. All the particles are exist in a separate or individual entity. Okay, it cannot force a flux. Okay, it's why? Now because in this case all the particles are not attaching to each other, and it cannot form a network-like structure. So that's why it cannot. So that's why it cannot form a flux. Now come to the second point. When all the particles or when the flux will be formed, definitely the rate of sedimentation, definitely the rate of sedimentation is high. Definitely the rate of sedimentation is high. Clear? So why in the flocculated suspension the rate of sedimentation is high? And definitely when all the solid particles are attached to each other and forms a flux, and it increase the density of the flux. Okay, so after attaching all the particles, it enhance the density of the flux. That's why the rate of sedimentation is high. That means within fraction of time all the flux sedimented on the surface. But in this case, okay, but in the non-flocculated or deflocculated suspension, all the particles or the rate of sedimentation is very slow. The rate of sedimentation is very slow. Okay, the rate of sedimentation is very slow. Why? Now because in this case the solid particles or the single solid particles takes the maximum time. Why? Now because the single solid particles have a less density, so that's why it takes the maximum time to sedimented on the surface. Clear? So that's why in the deflocculated suspension the rate of sedimentation is very slow. Okay, but in case of flocculated suspension, the rate of sedimentation is high, very high. Clear? Now the next point is, in the flocculated suspension, the supernatant liquid, okay, the supernatant liquid is clear. So what do you mean by supernatant liquid? Okay, so the liquid medium, in this case the liquid medium is called known as supernatant. Okay, supernatant liquid is clear. Why the liquid or why the supernatant liquid is clear? Now definitely when all the particles forms a flux, okay, in that time the rate of sedimentation is high. That means within a fraction of time or in less time all the flux sedimented on the surface. And okay, and when you will see the medium, in that time definitely a clear liquid will be visible. Why? Because in this medium there is no solid particles are dispersed. Why? Because all the flux sedimented on the surface. That's why the supernatant liquid is clear. But in case of deflocculated suspension, the supernatant liquid, okay, the supernatant liquid is cloudy. Okay, but in case of deflocculated suspension, the supernatant liquid is cloudy. Why in case of non-flocculated suspension the supernatant liquid is cloudy? Now, because in the deflocculated suspension, the single solid particles, due to less density, it takes the maximum time to sediment on the surface. Okay, and when you will see the medium, in that time definitely one or more solid particles dispersed in this medium, and that solid particles try to sediment it on the surface. So that's why any time when you will see the medium, in that time the supernatant liquid is cloudy visible. Clear? But in this case the supernatant liquid is clear. Clear? Now the next parameter is, in the flocculated suspension, it does not form a hard cake. So what do you mean by hard cake, or how the hard cake will be formed? Let's see. Look at the figure. Okay, look at the figure. When the flocks sediment on the surface, in that time, in the flocculated suspension, in the flocculated suspension, the flocks are sediment on the surface and loosely packed. Okay, when the flocks sediment on the surface, in that time it loosely packed. Okay, that's why it does not form a hard cake. And when you have to shake well, okay, before use, when you are shaking, in that time all the flocks again it will be redispersed throughout the medium. Why? Now because it is loosely packed to each other. Okay, so due to on gently shaking, all the flocks are again redistributed throughout the medium. Okay, that's why it does not form a hard cake. But in case of deflocculated suspension, it forms a hard cake. Okay, in case of deflocculated suspension, it forms a hard cake. Why? In the deflocculated suspension, it forms a hard cake. First of all, you should know that if the hard cake will be formed, so what will be happen? If the hard cake will be formed, when you have to shake well, in that time the dispersed particles or the solid particles are not redispersed throughout the medium, and you can take the required amount of dose. Okay, so that's why the deflocculated suspension cake is not a patient acceptance. So now comes the point, why in deflocculated suspension hard cake will be formed. What is the reason behind this? Because in the deflocculated suspension, all the solid particles are exist as a separate entity. Okay, and all the solid particles are slowly sediment on the surface. Okay, so first one, suppose this particle is sediment on the surface, next this particle, next this particle. So due to exist as a separate entity, the solid particles sediment on the surface are very slowly. That's why all the solid particles, when sediment on the surface, in that time it tightly packed on the surface. It tightly packed on the surface. Okay, so when all the particles are sedimented on the surface, in that time it tightly packed. There is no any void space will be occur. Okay, so due to tightly packed, it form a hard cake in the deflocculated suspension. Okay, so when the hard cake will be formed, when you are gently shaking or when you are shaking, in that time it cannot redisperse throughout the medium. Okay, so definitely you have to avoid the hard cake formation in the pharmaceutical suspension. Clear? Okay, in the flocculated suspension, when you will take the dose, in that time some solid particles, okay, suppose this one is the 5 ml cap. Okay, the 5 ml cap, and when you will take the 5 ml dose from the flocculated suspension, in that time some solid particles are stick on the wall of the cap. What will happen? Now when you can take the 5 ml dose in a 5 ml cap, in that time some solid particles are stick on the wall. Why? Now because the flocculated suspension, the viscosity is very less. Okay, so due to less viscosity, the solid particles stick on the wall. Okay, but in case of deflocculated suspension, due to high viscosity, the another point is, due to high viscosity and due to less density, the solid particles takes the maximum time to sediment on the surface, and when you can take the dose, in that time the drug, the solid particles, the solid particles dispersed inside the medium. Okay, that's why when you can take the dose in the 5 ml, so it cannot stick on the wall. Why? Now because the solid particles present inside the medium, because the medium is high viscosity. Due to high viscosity, the solid particles in this case do not stick on the cap, but in this case the solid particles stick on the wall. Okay, so my dear students, so that is the difference between the flocculated suspension and deflocculated suspension. Again, I am repeating that part so that you can easily understand what I am telling, the flocculated and deflocculated difference between. Okay, so first one is the in flocculated suspension, all the solid particles are loosely aggregates and attached to each other and forms a network-like structure. That's why it forms a flocks. Okay, so due to formation of flocks, the rate of sedimentation is high. Okay, why? Now because the density is more. Okay, and the next thing is the supernatant liquid is clear. The supernatant liquid is clear, and the and in the flocculated suspension it does not form a hard cake. Clear? But in case of deflocculated suspension, all the solid particles exist as a separate entity. Okay, exist as a separate entity, and it cannot form say flocks. Okay, and the solid particles takes the maximum time to sediment on the surface. That's why the rate of sedimentation is very slow. So the supernatant liquid is cloudy. Okay, and it forms a hard cake. Okay, in this case the solid particles stick on the cap, but in this case the solid particles do not stick on the cap. Clear? So that is the basic difference between the flocculated and deflocculated suspension. Thank you very much, my dear students.